Hello, this is Fred G. York. This is a presentation on the structure of your data analysis. I'm at the University of North Carolina, Bloomington. This is what this presentation is about. You will be provided guidance on what you need to know before you seek a statistical test for your data when you're conducting an evaluative study in the human services. We're only talking about selected applications of human service evaluation. Not just any kind of statistic for any kind of purpose, but just certain ones for evaluative studies. This means you have collected data and wish to examine it statistically. This also means you know what statistics do and are familiar with such concepts as the value of P and so forth, although you're not expected to be familiar with any particular statistic. This is just for selected evaluative studies, not just for any kind of study. There's a different presentation for those seeking statistical tests for other types of studies that I've done, and others I'm sure have done also. This should help you with the use of a special table designed by me. It also will provide you with guidance on finding statistic. If you have the data table, that is the particular table that I have designed, this will be a way of helping you make use of that particular guide. This provides guidance on the appropriate statistic to employ, the name of the special York Excel file for using that statistic, and a YouTube presentation by me that illustrates this particular procedure. So there are two things this will do. It'll help you find the statistic, and if you have this guide, it'll provide you with some help in using that particular guide. Here are key questions to ponder. What is your research design? That's the first thing we're going to talk about. Secondly, at what level is the dependent variable measured? In evaluative studies, the dependent variable is always the client's target behavior. So that is what we're talking about by dependent variable. What are you measuring for the client in order to evaluate effectiveness of the intervention? What is the structure of your data? For example, am I comparing pre-test and post-test scores for a single group, or gain scores for two groups, or treatment and baseline scores for a single client, or something else? Those are just examples of structure of your data that you'll need to be able to be familiar with in order to make use of this particular guide. The research designs included in this presentation will be the one group pre-test post-test design, where you have pre-test and post-test scores for a single group of people. The comparison group design, when you're comparing the scores of two groups, in this situation, typically we are talking about comparing the gain scores of two groups. Two groups have had pre-test and post-test scores. You've computed a gain score for every person. So each person in each group has a gain score to be compared. You could also use this just to compare the post-test scores, but that's not what we'll illustrate here. Post-test only group is when you only have data at the end of treatment, but no data beforehand. And if you're comparing post-test data to some kind of threshold of functioning that normally represents where people are before they get service, or if they have not had service. The AB single subject design is when you are comparing treatment scores to baseline scores for a single client. There is the limited AB design. You're comparing treatment scores to a single baseline score. The limited AB design is something I have conceptualized. It's not something you'll see in other textbooks on research methods. But it's when you only have a single baseline score and you have a set of treatment scores and you want to compare them. That's a little unusual, a little different than the normal AB design. Level of measurement is something to consider in regard to finding a statistic. There are 4 levels of measurement, but we include only 2 in this system of data analysis for human service evaluation. We're going to go over the different levels quickly, but then boil it down to only 2 major options. The 4 levels are nominal, ordinal, interval, and ratio. We have a shortcut. We only include in this guide nominal variables that are dichotomous. We call them categorical variables. And the other shortcut is we treat ordinal, interval, and ratio variables the same and call them scale variables. So just two situations we have in this situation. Let's go over the different levels of measurement in case you are not familiar with that. Variables measured at the nominal level place answers into categories such as male or female, political party affiliation, Democrat, Republican, and things of that nature. So here are some examples. What is your political party affiliation? And you'd have several categories. These are not designed as open-ended questions, by the way. They're designed as you can fill in the blanks. There will be categories after each of these questions. Political party affiliation question may have Democrat as one category, Republican as one category, and other as a third category. So these are some different examples where the nature of the answer will provide you with a nominal variable, which means people are placed into categories which have no order. Ordinal variables, on the other hand, are variables where people are placed into categories that are ordered from low to high. An example, how much do you agree with this statement? My wife will get better. My life will get better. I'm sorry, my life will get better. So you answer strongly agree, undecided, disagree, strongly disagree. These are in an order. Strongly agree is the most positive answer, and strongly disagree is the least positive answer, and everything else falls on a scale between the highest and lowest. Interval variable are variables measured at the interval level that have values that are numerical in nature, like scores on a test, or height measured in inches, or weight measured in pounds, and things like that. Theoretically, the distance between values are equal. We're not going to talk a lot about that, but that's what you find in the textbooks. We only include two types of variables in this analysis. We're calling it a shortcut because we're not following the tried and true, all the rules of measurement that are most sophisticated for the most sophisticated scholar who is doing research. The two shortcuts, we only include nominal variables that are dichotomous, meaning you have measured behavior as something like yes or no. If it's nominal, it has to be dichotomous in order to be in our system of data analysis presented here. Number two, we treat ordinal, interval, and ratio variables the same and simply call them scale variables. Data structures for one group pretest, post-test design. Here are a couple different possibilities you may be facing in your situation. You are comparing a set of scores to a single score for a single group of people. If you do a pretest, post-test, and you're unable to match each person's pretest score with a post-test score, what you can do is do a mean of the pretest, compare that single score to all of the post-test scores for that single group. That's this particular situation. Number two, you're comparing a set of matched scores for a single group. If you can match each person's pretest score with his or her post-test score, you can, that's one situation where the system will work for you. Number three, you're comparing the proportions of positive measurements at two time periods for a single group when the dependent variable is measured as a dichotomy. Again, a dichotomy is either yes or no. Data structures for comparison group designs, you're comparing the scores of two groups. Number two, you are comparing the proportions of favorable behavior between two groups of people when you have a dichotomous dependent variable, such as improvement, yes or no. And you're comparing two groups, your treatment group and your comparison group, in regard to whether each person there was categorized as improved or not improved. Data structures for A/B single subject design. You're comparing a set of treatment scores. Number one, you're comparing a set of treatment scores to a set of baseline scores for a single client. That means you have several treatment scores for this one client, and you have several baseline scores for this one client. Number two, you're comparing a set of favorable treatment behaviors to favorable baseline behaviors when the dependent variable is measured as a dichotomy, improved or not improved. This is for a single client. The limited A/B design. One structure, you are comparing a set of treatment scores to a single baseline score. By the way, every time I use the word score, I'm talking about something that is scale in nature, either ordinal or interval. So data structure, knowledge about data structure leads to finding a statistic for your study and locating the special York Excel file for the analysis of your data using the statistic. And with the special table, you can also find a YouTube presentation by me that illustrates the use of your special Excel file. This is the name of that table, by the way, using Excel for statistical analysis of data for human service evaluation. And here is that table, just to illustrate it right here. I don't know how well you can see that, but if you can see it, let me just explain it to you. You have a table here which has the first column is research design. So you find the research design in this column that's appropriate to your situation. Level of measurement, then you go over and find what is the level of measurement. Data structure, the kinds of things we just talked about, find that one for you here. If you don't find it here, then you can't use this particular system. This column will tell you the statistic that's appropriate for that situation. This next column will give you the Excel file if you have access to it through the book I've written entitled Statistical Analysis of Data for Human Service Evaluation, published by Sage Publications. And here's a PowerPoint presentation also available there, and also a link to a YouTube presentation that illustrates how to use that particular file for analysis. I hope this has helped you, and good luck.